Hello, I'm Alejandro Silva, fabrication engineer at FabLab El Paso. In this video, I'll show you how to set up a job in the CNC router so you understand better the process of how these parts are manufactured and see how easy it is. So what we're going to do is this little FabLab logo that I designed. It has some features that I like you to see that shows limitations of CNC machining. If you're either making a component that will be part of an assembly for a functional machine or something that will be displayed as a sign, the process has the same principles. You acquire a 2D vector file, import that into a specific software for this kind of jobs, then specify your toolpaths, then execute the job. It's a little more complicated than that, but it's still quite easy. So from the part that I just showed you, we need a vector file. This is the set of lines and curves that make a 2D pattern, and the machine uses those lines to know where to move. You'll see later how to create those 2D files, but for the moment, I already have mine for this job. So the software that we will use is Aspire from Vectric. It has many tools to create 2D and 3D patterns with CNC machining. It is quite easy to learn and has many advanced features that we won't really use. With this software, you just basically tell it what cuts you like to do, how deep to go with that tool, and then it automates the CNC movements for you. There are many other free programs that you can use that can be easier for you, but all of them work under the same logic. So let's open Aspire and let's create a new file. And depending on the part that you like to do, the size of the canvas differs, but you must know your machine. So we at FabLab, we have two CNC routers. Here at the workshop, we have our CNC machine with a workspace of 8 feet by 4 feet and 6 inches tall. It is important to know this because if you have a machine that is capable of smaller areas, then you need to reconsider the strategy of manufacturing your job, like this small CNC. It is convenient for small parts, but what I want to do, I cannot do it in here because it doesn't fit. If you only have access to a machine like this, then maybe you split your file in half and then glue it at the end or use screws. But anyway, we know that our equipment is capable of creating this part, and I know that my file is about 13 by 6 inches and the material that I have is 15 by 8 inches, a little bigger than the part that we're creating, but that's what we need because we want some extra space for adding the nails around and tabs, and just so you have a little bit more of room for errors of positioning. So now I'll create the workspace of 15 by 8 inches, the size of my material. It is important that you work with a set of units in a specific. Huge disasters had happened because one person was working with inches and another one with millimeters. So here at FabLab, we have established the use of inches for our CNC machine. So my files must be on inches. I'll select inches here. And now the C0 position. I'll put it on top of the material and you'll see what this means later. Now the XY downturn position is where I want my 0 on X and Y. And I'll select this corner. This is your preference. And in some jobs, it might be easier to do it in the center. But in my experience, this corner has been the easiest for me. And now I'll select OK. Now that I have my empty workspace, I'll import my vector file. For this, I just go under File, Import, and Import Vectors. And it's asking me to select my file. I have it right here, FabLab token millimeters, and I'll open it. And this is why everyone should use the same units. It's huge. And what happens is that vector files don't specify the units. It just reads it as units. But since we know it's wrong, we can just scale it or have another one saved in inches. For this, I'll just open the right one saved in inches. And I'm going to center it over here. So I know it's not close to the edge of my material. Now, there are many cuts that you can do with the same vector. You can tell it to do a profile cut, and the tool will move along that line, either from the outside, the inside, or the middle. You can also create pocket toolpaths, where you select an area and it removes everything on the inside. Those two are the most used, but there are others to make holes like a drill or use special tools to engrave letters or 3D textures. So as you can see from my original file, these sections that I'm selecting are pockets. Also, the letters are pockets, but inside another pocket. Only the outside is a profile. So here in Aspire, I'll select the pockets that I want to do first, and all of them will have the same depth. That's why I can select them all together. But if you want other pockets with different depths, you'll have to create those toolpaths separately. Also, you need to select your toolpath accordingly. There are many different types of bits. We have end mills that will cut in the same shape of a cylinder, but we also have ball nose with that circular end, or V-tips that have different angles, and many more with different shapes to do different types of geometry. Most used ones are the three that I just mentioned, and you can select them in Aspire if you go to Tool, then Select. There are many specified there, but if yours is not on the list, you can always create a new one and then you input the parameters of your tool, like the diameter or the angles, but all of that is specified in the package that the tool comes in. You don't have to do any measurements. And in this section, you can click Edit and you can change things like how fast you want the tool to rotate or the speed to cut through the material. Even if you use the same tool, these settings change according to the material that you're using. For soft materials like MDF or some foams, you can get away with cutting faster, but if you go with aluminum, you'll have to go slower. Always do some research on these parameters for your tool and material in specific, and you can also do some tests where you make some experiments in the material that you use just to see how clean the cuts are and adjust speeds accordingly. For this job, I'm going to select my 1/4 of an inch end mill. I want to go 1/4 of an inch deep, and since it's soft wood, I know I can get away with doing it in one pass. It's good practice to not go deeper than the diameter of the bit, but also this depends on the material and the length of the bit. I'll check my speed rates, and this is a material that I know and I have tested these settings before. Sometimes you want to do more passes so the vacuum on the CNC cleans everything more, but you'll see how that works later. Now I'm going to hit Calculate. It will generate the toolpath for this specific tool. And here you can see a preview of how it will look. As you can see, it didn't cut all the geometry because the tool is thicker than some sections, but you generally go with thicker tools to get rid of most of the material fast, then switch to thinner ones to do more detail. Otherwise, if you do everything with a small tool, the job will take considerably more time. But you also want to do all the jobs that you can with the same tool before you switch to the next one, because you don't want to switch the tools over and over many times. It is more work and makes the job take longer. So I'll go back to my vector views, then select the outer profile where I want to cut the overall shape out of this block of wood. Now on toolpaths, I'll select the profile, and for the cut depth, if you want to cut through all the material, then just cut a little bit more. I like to do about 0.05 inches more than the thickness of my material. I'll select the passes that I want, outside of course, and then I'll add tabs. This is very important because if you don't do it, this piece of material won't be fixed to the bed surface and it can break the tool or ruin the piece. And since I still want it rigid for the next jobs, then I'll add tabs. Depending on the material or the job, tabs won't be an option and you'll have to reconsider using other methods to fix your material into the spoil board, like double side tape. But for the material that I'm using, I'll use special nails that I'll show you better later. So add tabs, then edit tabs. And you want to put the tabs strategically in places where it is easy to remove and where the piece will hold rigid. So usually that's flat surfaces distributed along the piece, and the length and thickness of the tab depends on your material. So you can also test that out. Tabs that are too small might break in the middle of the job, but if you got too big, they would be very difficult to remove. So now we calculate the job. This is a warning saying I'm going to cut through the material. I'm aware of that. That's what I intend. Okay, then see the preview. So everything looks good and you can see the tabs. Okay, now I'll do the toolpath for the other tools. My next tool is a 1/8 of an inch bit. So I'll go to the 2D view, then select the pocket that I cut before. And just so I don't go over areas that I already cut and don't waste any time, I'll do an offset. I'll do 0.25 because that's the diameter of the tool that I previously used. And then I'll select also the new pockets. Now, I know this looks very confusing, but when you select one pocket inside of another, the software knows that you intend to do the pocket in the middle of those areas. So that's what's happening here. And if I hit calculate, you'll see in blue all the lines where the tool is going to be moving. And as you can see, it avoids the sections in the middle that we already cut. I'll see the preview. And as you can see, those corners are a bit sharper now. If we want them even sharper, we would need a smaller tool. But for this application, that doesn't matter, and I like the way it looks. Now, I'll select the letters and I'll do exactly the same, but going even deeper because that first pocket already cut 1/4 of the depth. And when I go to preview, it doesn't look good, right? So I'll repeat the process, but with a different tool instead. And instead of doing a pocket, I'll do a V-carve, which is special for letters. And when you see the preview, it looks like this. Beautiful, right? Okay, now we will save it as 3 different files that we will execute one after each other as we finish the job with each specific tool. First, the job number 1 toolpaths. For the post processor, I'll select the one for the machine that I have and in inches. And I'll do the same for the other 2 jobs. By the way, you can estimate how much the job will take if you go to this section, select all your toolpaths, and then make sure scale factor is at 1. Then this is telling me that in total, the job will take about half an hour, plus of course the time it takes to manually switch the tools. Now, here at the workshop, I'll turn on the CNC, make sure that the safe box is on, and that everything is good. In the computer that controls the CNC, I'll run the home routine for X and Y, where the CNC moves till it hits the proximity switches, and I'll know that my tool will be located in this corner. I can either locate the material there, or if I want to locate it somewhere else, I'll manually home it there later. So I'll put the material where it's more convenient for me, make sure that it's well aligned, and using these special nails made of plastic, I'll nail it down. It is very important that you don't use the nails that are made of metal because it could damage the tool in case your CNC cuts through it. These nails are special in the way that they can be cut like wood with the same tool. I'll move the tool all the way to where I want and then manually zero it there. Remember, the 0 position has to match the 0 position on your file, which is in this case the corner at the bottom left. We also specified 0 on top of material, so I'll locate my tool over this section on top of the material, and that's the area that I'll use later when I have to re-zero with other tools. Then, in the same manner, I manually hit 0 Z-axis. I'll run a spindle warm-up routine, and after it's done, which is about 5 minutes, we will be ready to start. Warm-up is finished. We have the right tool in the spindle, and of course, safety equipment on, which is safety glasses to protect our eyes, ear covers because it can get quite loud in here, and the vacuum clean and running so it cleans all the debris, preventing it from us inhaling that or making a mess or even starting a fire with the friction of the tool. We let it run, and once it's finished, we switch tools, re-zero only the Z-axis because X and Y must remain the same, and we select the next job and repeat. Once all jobs are done, we will remove the tabs, and here it is, our part cut just as we designed it. Many times, some post-processing is required, sanding or manually cutting some edges, but overall, this is the process that we go through when we use the CNC. Thank you for watching. I hope this wasn't intimidating. Believe me, it takes about 3 jobs to start getting the notion of this.